Welcome to PG-4. This is a pre-POGL activity, and today we're going to focus on naming and drawing alkanes. Alkanes are compounds, organic compounds that just have carbon and hydrogen single bonds only. Your learning objective for this pre-POGL activity is to be able to take names and convert them to the skeletal structure, to the skeletal formula, and then also to take the skeletal formula and convert it to the name. So there are some things you're going to have to memorize. So I'll go ahead and tell you what they are. So the prefixes. And if you just do number of carbons 1 through 10, that should be enough. It's been enough for me. It should be enough for you. And these prefixes are meth, S, prop, but, pent, hex, hept, oct, non, and dec. And then the suffix for the alkanes is the A and E. So ane, 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 ane. So methane becomes methane, and that's just a CH4. Ethane becomes this, which is CH3, CH3. Propane becomes this, which is CH3, CH2, CH3. These are the condensed formulas. Butane, 1, 2, 3, 4. Pentane, 1, 2, 3, 4, 5. Hexane, 1, 2, 3, 4, 5, 6. Heptane, which is 7. 1, 2, 3, 4, 5, 6, 7. Octane, 8. 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, nonane and decane. Okay, so I'm going to give you some rules, and your rules are how to name structures. Okay, so the first thing you want to do, number 1, is find your longest continuous carbon-carbon chain. And then number 2, you want to, I like to circle the substituents, and then go ahead and name those substituents. And then number 3, we're going to number the carbon-carbon chain from the side that gives your substituent the lowest number. And then we're going to put it together. And when we put it together, the whole name, you put commas between numbers. So if you have a number, you put dashes between a number and a letter, and then no space between letters. So those are our four rules, and let's try an example. Okay, so hopefully you're writing this stuff down. Okay, so here we go. This is a skeletal formula. And we want to do first, we want to find the longest continuous chain. So 1, 2, 3, 4, 5, 6. Okay, so that's our longest continuous chain. I will put it in red. And there's 6 carbons. So 6 carbons is what? Hexane. Okay. And the second thing we want to do, circle the substituents. The substituents are the compound, the functional groups of the carbons that are coming off of the long chain. So here we have, and this is just one carbon, so it's a methyl. Now substituents, they don't have the ane, they have the YL. Okay, so il means it's a substituent. That's the suffix right there. So methyl. And then we have to give it the side that is the lowest. So if you started here, it'd be 1, 2, 3, 4, 5, 6. If you started here, it'd be 1, 2, 3, 4, 5, 6. So obviously you want to do the yellow 1, 2, 3. That gives this 3-methyl instead of a 4-methyl. And so then you put it together, and it would be the substituents come first, 3-methyl hexane. And you have a dash between the number and the letter. And so that is how you name that compound. Okay, so let's try to convert a name into a skeletal formula. So name into skeletal formula. So I'll give you a name, and then you draw the skeletal formula. So let's draw 2-ethyl pentane. So the first thing you want to do is you want to go with the longest chain. So you kind of work backwards. Pentane is 1, 2, 3, 4, 5. 5 carbons. And then you have your substituent is ethyl, and it's on the second carbon. So 1, 2. You could have started from this side, but 1, 2, 3, 4, 5. And then there's your 2-ethyl. Okay, so another thing we need to talk about is what if you have multiple identical substituents? So an example would be this compound here. So how would you name that compound? Well, you find your longest chain. Carbon-carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons. That is octane for your longest chain. Now your substituents, this one, and this one. So now you want to number it. You could either start here, 1, 2, 3, 4. That gives it a 4. Or you start here, 1, 2, 3. 1, 2, 3. 3 is lower than 4. So you want to start from the left. 3, 4, 5, 6, 7, 8. So we have a 3-methyl. We have a 4-methyl. And we have a 5-methyl. Since these are all methyl, then they need to be combined. And when you combine these, you have to use a prefix for the so there's going to be 3 of them. So you use trimethyl. So it would be 3, 4, 5 trimethyl. And so when you put this all together, the name becomes 3, 4, 5 trimethyl octane. So if you have tri, because you have 3 methyls, you better have 3 numbers. That's how I remember it. And there's di. You pretty much only need di, tri, and tetra as your prefix to memorize. I don't think I've ever seen it go higher than tetra. Okay, so there's 4 more substituents that you need to memorize. And these are the branched ones. So I will give these to you. you have, when I go here, this is where it's added onto the ring here. So 1, 2, 3, and this makes a Y, isopropyl. So these are branched. This is isopropyl. Propyl meaning 3 carbons. Iso I think of as a Y. This is tert butyl. So you have 1, 2, 3, 4 carbons. There's your butyl. And I always think of it, it makes a cross. Tert butyl. And then we have another Y. And this is called isobutyl. And so if you see this here, we make a Y. So there's your iso. And there's 4 carbons here. Instead of this one has isopropyl because there's 3 carbons and it's connected. This one has 4 isobutyl. And then the last one that you have to memorize is sec-butyl. So once again, we have 4 carbons. 1, 2, 3, 4. There's your butyl. And this comes off of a secondary carbon. This is a secondary carbon. There's a carbon connected to 2 other carbons. 1, 2. So that's the branched. So let's do an example. So convert this structure to a name. Okay, so once again, you find your longest chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4. It doesn't matter which way we name it. 7 is heptane. And then you've got to, there we've circled our substituent. This is 4-isopropyl. And if you have a lot of these substituents, you put them in alphabetical order. That's who gets to be added first when you combine the name. So this is 4-isopropyl heptane. Now, sometimes you're not going to have a straight chain. Sometimes you might get a cyclohexane. So here's a cyclohexane. And so when you get a cyclohexane, you still find the longest cyclo. So 1, 2, 3, 4, 5, 6. So cyclohexane. So instead of just hexane, 6 carbons, you put the prefix cyclo. And that way you know it's a ring. And then your substituents are here. This is isopropyl. And then this one here is a methyl. Now you have to, when you number these, you have to give one of these substituents the number 1. And then you can go clockwise or you could go counterclockwise. If I went counterclockwise, it'd be 1, 2, 3, 4, 5. So your would be a 1 and 5. That's not as good as the 1 and 3. So it becomes 1 isopropyl. The I comes before the M. Dash 3 dash methyl cyclohexane. Okay, so I will give you an example. We'll work on this example and then I will give you your pre-POGIL activity. So let's try to draw this one. In fact, this will be your pre-POGIL activity. So your pre-POGIL activity due tomorrow is to give me a name for this compound here. Okay. And then give me a name for this compound. and then convert this into a skeletal structure. So let me give you the name. I want you to draw 3,4 dash dimethyl hexane. 3,4 dash dimethyl hexane.